So, yep, this evening's presentation is entitled Greenhill Junction Improvements over the Festive Period 2023. And whenever you're ready, David, take it away.
Okay, thanks, Craig. So, just touching on the Rail Systems Alliance Scotland, not everybody might know about it. So, Rail Systems Alliance Scotland is a partnership between three parties. So, you've got Network Rail, who are the asset owner and the client, Babcock, who are the construction partner, and Arcadis, who I work for. We're on the design side. We've been delivering S&C renewal, plain line renewal and enhancements since 2019, started control period 6. And we've recently been awarded domestic renewals for control period 7, which starts next month. Picture there is of Carstairs remodelling, which was an enhancement. Am I on mute here?
No, the ocean.
Oh, is it coming through the L?
Yeah,
Okay. Yeah, picture there is of Carstairs, which is a recent enhancement that we had. The most recent S&C renewal that we had was at Greenhill Upper Junction, which is the subject of tonight's presentation. Next slide. Thanks.
Maybe start slow now. So it was working in the rest of it.
No, exactly. Sorry about this.
Is it fucked up one?
2 seconds. Let's try it again. Yeah.
Yeah.
Okay, sorry about that, guys. And that's working now. Yeah, so the most recent S&C renewal that we had is Greenhill Upper Junction, the subject of tonight's presentation. So where is Greenhill Upper Junction? So it's a key junction in Scotland's railway, approximately 4 miles west of Falkirk on the Edinburgh-Glasgow main line, locally known as the E&G. The Greenhill Upper Junction is where the Greenhill branch diverges from the main line, heading towards Greenhill Lower Junction and then towards the north. So the works that we did over the festive period was actually the second phase of our rationalisation of Greenhill Upper. The first phase took place in 2015, and as you can see from this diagram here, which shows the layout of the site prior to 2015, there was a lot more railway there. So as part of the works in 2015, 6 point ends and a lot of plain line was recovered, including a complete removal of the up branch goods loop. The up branch line now diverges after the works. It now diverges 350 yards further towards Glasgow. So it's a much simplified site at this point. Far less maintenance required at the junction, while still maintaining the function. So that was a big improvement for the maintenance teams. So second phase, one of the centerpieces of the second phase, which is the work that took place over the festive period, was the replacement of this switch diamond, switch diamond 125 Bravo Charlie. So this is the route from the down branch line onto the down main through the up main. This switch diamond here was causing issues with the maintenance, and it was regularly failing due to heat-related expansion of the switches, leading to detection issues. So this was a persistent headache for the local maintenance team. So this was the centrepiece of the works that we were doing over the festive period to take this out. So this is a diagram of the works over the festive period. So those of you not familiar with the colour coding, the green items are removals, recoveries. The red items are new pieces of track, and blue are pieces that are either refurbed or realigned. So you can see from that the 125 ABC route through the switch diamond that we're having issues with has now been replaced by a ladder arrangement where you've got a new crossover 122 Alpha Bravo between up and down main, and then a turnout 125 from the up main connecting onto the down branch. All of these are at 70 mile an hour turnouts, NR60 Mark 1G 33.5 switches. The other point end that was renewed was 126 from the down branch onto the down goods loop, so CV 9.25. So in addition to the renewals that we had on the site, we also had 4 point ends to be refurbished. 121 Alpha, and 127 Bravo in the down main, 121 Bravo in the down goods loop, and 153 Bravo on the down branch. And also the abandonment of 2 trap points on the down branch goods loop. This is no longer a freight line categorisation, which is the reason for the removal of the strapping arrangements on the site. So this is just a high-level summary of the track renewal specification. So in terms of the refurbishments, the refurbishment was bespoke to each turnout, but as a minimum, it was replacement of the screws, clips and ferrules, and re-gauging to the track construction standard tolerance. And fairer replacements in each of the refurb items, and that was dependent on the condition assessment that was done. So from a track design point of view, this was our timeline. So we started working on the approval in principle design in November 2022, which is about 13 months prior to the core works. You can see the 3 stages there. So you've got approval in principle, detailed design, and then AFC design. So each of those stages, we would have interdisciplinary reviews between the different design disciplines, and also an overview by the construction teams. So we had a long-standing target within the Alliance to achieve T-12 for our AFC design, and this was the first time we achieved it for Greenhill, which we were quite pleased about. So that AFC was achieved in late September 23. So I'm just going to touch on a couple of issues that we had on the track design side. This is under Bridge 79, which passes under the up and down main towards the west end of the site. So the design development had looked at this bridge, and because of the concerns of the loading, the vertical design took this into account, and we had very little lift over this bridge. But when we submitted the information to the design information to the structures team within Network Rail, they were concerned about the lateral loading that there might be to the parapet on the downside, which is the right hand side of that photograph. And the reason for that is that we were proposing a slew of just under 50 millimetres. And they were concerned about, as I say, about the load that this would put on the structure. And they asked if we could limit that to 25 millimetres. So we were a bit concerned about this because that straight that you can see going into the distance, that stretches pretty much all the way through our site, 640 metres long. And because we were given this instruction fairly late in the design process, we were concerned that it might have a knock-on effect and cause us an awful lot of headaches. But in the end, we were able to put in a flat curve just beyond the S&C you can see there, which changed the bearing of the straight through the bridge and reduced the slew in there to under the 25 millimetre restriction that we'd been given. So that sort of removed that headache. Another issue that we had was over the refurbishment of 121 Bravo, which is a set of trap points at the west end of the down goods loop. The original plan was to change the radius at the trap points and have the clearance point moving from its existing position towards Glasgow to the toe of the trap points. And the issue we had with this, the construction team raised the concern that we changed the radius and implemented the slew there, which is well over 100 millimetres. They were concerned that there would be problems with the point operation after installation. So the first thing we had to do before we went any further looking at options was to check that the signalling design side of things was going to be compliant if we did move that clearance point back towards Edinburgh, towards the right hand side of that diagram there. So we consulted them and they said that there was no restriction to that. So we ended up moving the clearance point, and as a result, also the axle counter and the insulated joint that you can see there that's on the fronts of 121 Bravo, they moved approximately 10 metres towards Edinburgh. So the result was, if I just move on to the next slide, you can see that we no longer replaced the steelwork through 121 Bravo. The alignment was a best fit to what was there before, and the clearance point, as a result, insulated joint and axle counter moved towards Edinburgh, and there was no longer any concern about the point operation afterwards. So I mentioned signalling design there. There was a major signalling project that ran parallel to our renewal works, the Greenhill Signalling Resilience Project. So this is a very large piece of work, and Greenhill Upper Junction was just a very small part of the footprint of their project. So this work started in June 2022. It's still ongoing at the moment. It finishes in April this year. You can see on the bullet points there some of the quantities of their works, and just like a brief description of what they had as part of their work bank. We had to have integration with this project because there was overlap with them coming into the sharing the sort of possession access that we had, and there was plenty of scope for there to be conflict. So we set up regular integration meetings between the projects early on, I think as early as April 23, and that was going on a sort of monthly basis. And then that these became more regular on the approach to the core works. From a track design point of view, one of the main interfaces was when it came to the design and the track construction. There were some instances where insulated joint locations in particular might have not been in an optimum place from a construction point of view. And we had to, if there was an instance where we wanted to propose a new IRJ location, we had to make sure that that was going to be feasible within the scheme plan that the GSRP had. And we also had to do gauge assessment of new signals that were going in on our site, such as the banner repeater, which is in the picture there. Overhead line electrification. So the list of deliverables there, and quite a lot of work involved for the OLE team. This was probably know it's quite a recent electrification site, but electrified within the last 7 or 8 years, I believe. But the change in the footprint of the track meant that there's quite a lot of work to be done on the portal structures. 7 portals to be reconfigured in total, recovery of cantilever structures, and also the modification of cantilevers in the portal structures to accommodate the new track position. This next slide shows gives you an idea of the modifications involved. You can see again same colour coding as before. Green shows previous position, and red shows the new position. So you can see that there's a crossover there in red. Then this obviously wasn't there previously, so the overhead line is repositioned to accommodate that. There's a tow movement there of approximately 60 metres towards Edinburgh, so a lot of work required on that structure and for spans either side. Overhead team also, for every modification they did to the cantilevers, they had to then make assessment on the changes to the forces applied onto the structures. So yeah, that from an overhead line point of view, that area of the site was probably the biggest headache that they had. EMP design, and primary work for them was points heating. So 9-point ends, where was a new points heating design required. DNO supply design, and transformers, track connection boxes, all linked to the points heating, as well as cable management design. Well, EMP design issue. One of the main issues that we had was the fact that the troughing routes that were on site were already over capacity, and as well as the point heating cabling, the GSRP were also having to install a lot of new cables on the site, and if that's your starting point, that obviously created an awful lot of problems. There was an exercise done between the GSRP and Rail Systems Alliance to identify how many of these cables were actually still in use, and it turned out that quite a lot of the cables were actually redundant, and that freed up a lot of capacity. And in the meantime, to stop any sort of delay to the works that were taking place, there was temporary protection put onto the cables that were laid on the site in the meantime. The temporary protection being split ducting. We'll move away from design onto the sort of planning of the job and the logistics. awful lot of the track on the site was panelised. So these panels were coming from Sandyacre in the East Midlands, where they've been produced by Progress Rail. So we had deliveries arriving on site as early as August, which was the rail delivery train, and then on 6 consecutive weekends from late October onwards. You can see the bullet that shows you the amount of panels that were delivered on each weekend. And the photograph there shows a tandem lift by the Kirov cranes from the panel delivery that came in by rail. The list there of the manufactured panels for the new S&C. 39 panels in total, well over 500 tonnes. And bear in mind that all of these panels were handled twice, from the laydown area to the laydown area for delivery, and then when it came to the core works, they were then moved again in a position. Photograph there is a closure panel on 122 Alpha Bravo crossover, the 16-tonne panel. So this slide's here, it's a wee bit small, but this is just to describe an issue that there was, again, with Underbridge 79, which I mentioned previously. There were loading concerns on the bridge during the core works as well. So the issue that we had here was that when it came to the largest panels, which were the G-switch panels, which were 34 metres long and 31 tonnes each, there was a ruling from the structures team that the Kirov cranes couldn't traverse that bridge while lifting one of these panels. And that created a problem because the laydown area was just beyond that underbridge. So the solution that came up with was that there was a configuration that you can see on the picture there. So you've got a crane at each end of a salmon wagon. So the crane that was at the far end, so the tandem lift. So the crane that was at the far end rested its side of the panel onto the end of the salmon wagon, so that it wasn't taking the load, and the crane at the bottom of the picture there was off the bridge. So it meant that the panel could then be traversed across the bridge without the axle loading on the crane actually going through the bridge. So that was done both at the delivery stage to take the panel up to the laydown area, and then again at the core and to take it back down into position. So that was a wee bit of a headache, but that was worked out in advance of the job about how they were going to do it. It's just a slide showing the various activities happening on site on each of the days of the core. So the work started at 10 o'clock on Christmas Eve and continued on until possession was given up just after 4 in the morning on the 2nd of January. As you can see, it's an extremely busy work site, and these activities had to be planned extremely carefully to avoid conflicts on site. Just to illustrate that, this slide shows how much work goes into the planning of the core works by the construction team. So there's one of these visualisation whiteboards for every shift within the core. So each of these whiteboards shows plant moves, possession limits, worksite limits, isolation limits, train moves, key activities, not just by the Rail Systems Alliance, but other parties that were working in the area. And the fact that the job went very smoothly on site, testament to the amount of planning that went into the job. Just a summary on the track construction side. There's some bullet points there. So 15 train movements, 2 cranes, 2 dampers, massive amount of ballast dropped and spoil removed, 179 welds in total, approximately 2 miles of rail, just to give you an idea of the volumes that were delivered in the works. So just to give an idea on the final product, so the red dots on this is a, if you're not familiar with it, this is a trace from the National Measurement Tray. So this will show you traces for horizontal alignment, top and twist. If you've not seen these before, quite often a way of finding out where S&C is, looking at these, is by seeing the amount of noise that's on one of these traces. So the red dots at the top of the screen there show the start and end of the S&C. The plot that's on the left-hand side is early December, before any works took place. And the right-hand plot is after the follow-up tamping. So you can see how much less noisy those traces are, which is really a measure of the track quality on the up main line, which is what's shown there on those charts. And there's just some images after the follow-up tamping. This is the up and down E&G 122 Alpha Bravo crossover. There's some photos taken by the techs on site after the follow-up tamping was complete. The lines were opened at 50 miles an hour on the 2nd of January, and the TSR was removed and the 100 miles an hour line speed reinstalled 1 week early on the 29th of January after the site had been fully welded and stressed. And that's it. It's quite a whistle stop tour maybe, but happy to take any questions.
Yeah, thanks, Dave. I'll just re-scan on the chat for any questions here. There's a few sitting there. Okay, Tom Wilson, don't know if it's a collaborative effort between Mark and Tom, but we'll... No, all right, okay.
One person. Asking just to help people understand.
Exactly. So Tom's asking, thermal expansion and loss of detection of switch diamonds are expected during normal summers. What might be done to mitigate this and increase reliability at switch diamonds for future hot weather events?
It's the period maintainer name.
Yeah.
Switch time.
Yeah.
It's summer.
Yeah.
It's 32 tomorrow. It's taps up weather.
Mm-hmm.
You're expecting a watchman or two. You're expecting loss of detection.
Yeah.
What do you think? An opinion of what might be done at switch times, I think, Greenhill, but like to try and get the detection a bit more robust. It's not the fact that the switch is unpaid, it's the detection that's not detecting them made. Is there something that could be done? Do you think?
Not too sure about that really, to be honest. I know it was causing enough of a headache at Greenhill that they sort of moved down the line of taking switch diamonds out completely to put the ladder in. But yeah, when it comes to existing sites, not too sure. I don't know if that's maybe somebody more from our maintenance, the maintenance side that might be able to answer that question.
I take it then you missed that one,
On the Greenhill before renewal, you mean? No.
I thought it would, because this install that's but instant. I may have missed what we'll do to something will Greenhill to actually install the same.
Yeah, if they've gone down the road of keeping the switch diamonds in, yeah, potentially that might have been an option. This a newer type of POE.
So
supplementary question, do you reckon your solution at Greenhill is the way it should be done for Switch Diamonds and abandon the idea of Switch Diamonds?
I think when it came to Greenhill, there was the option of going down the road of putting in a ladder. That wouldn't always be the case. It would depend on the footprint of the site,
If you've got room,
the limitations, exactly.
always room.
Yeah, so the fact that there was room at Greenhill, I think that's probably the reason that the option was taken and removed the issue of the switch diamonds completely.
I think when we had before the Alliance had it, and we were working on it, it was always they always, if you can take it out, take it out.
Yeah, that's really the impression I was given when I asked the question.
I think it's very much the case that was always the route to take it in that area. Because we did, going back, we did Pullman, we did Lambert Junction, both of these were remodeled to take out the Switch Diamonds. Lambert Junction looks fine, Greenhill looks fine when you show me tonight, Pullman looks awful, but it works, it was compliant, but it works. The previous solution of Pullman, of course, we polypipe the holes drilled in it, so that on a hot summer day, the signal turned on the tap and the water sprayed out. Maybe not quite where he wants you to spray, but it did work.
Yeah.
So I tell you, David, there was no first attack, but then there was no requirement for spares, or there was.
No,
Right, okay.
no.
Oh yeah,
Yeah, I'm
56.
sure
He's
you-
no system up to
Natural gas strategy to remove all the diamonds from the route, because I've worked in few projects which wanted to get rid of them, basically, and have a land agreement instead. That's fine, that's fine.
There's sometimes no alternative.
Yeah, if it stays, yeah, so if you're in the middle of London, that would happen.
Even in the middle of nowhere, Ely North Junction will always need to be an NR60 Mark II, I guess, switched down. Because you can't fit anything else in that footprint without buying half of the county.
Yeah. Gordon, that's a good question. You asked about NR60. Why did we use NR60 Mark 1? It's an ENG.
Fine, 56.
Actually, we use NR56 for part of the site, but on the ENG, it was NR60 Mark 1, and the reason for that was the previous phase that I mentioned in 2015 was NR60 Mark 1, and it was rather than have a mixture on the site, so that was the reason. But yeah, normally on that category line, on the main line, we would have had NR60 Mark 2. Yeah.
Now one from Tom there, slow restriction of the underbridge was solved by introducing a flat radius curve. Did this include the use of virtual transitions or other abrupt changes of camp efficiency?
Yeah, so there was a virtual transition at each end of the flat curve.
Which is all very TSI compliant, but
Yeah,
you know, we sometimes look at virtual transitions and go, oh, hang on a minute,
mhm,
you know, look at the RGD. Nobody else bothers about RGD.
yeah. I could tell you the value if you want.
Wait, but
Seconds. So no.
Yeah, we are trying to increase the limits of the RTD, isn't it? The next version of 202. Or they're trying to get rid of the restrictions.
I think we get it closer to the TSI will be, it'll be better.
22 millimeters a second, Tom. 22 millimeters a second of RGD.
Nothing.
Yeah, exactly.
That's a change in direction, that's great, that's it.
Yeah.
You get that in any straight in the line.
So yeah, that was the solution.
It's the kind of thing that people obsess about sometimes without understanding where passenger comfort comes from.
Mhm.
Or what the perception is of passenger comfort. There's some good work been done recently on passenger comfort levels by the RSSB. And I think we in this country need to put that into perspective. Bear in mind that up until the modern times, we didn't have spiral transitions.
Yeah.
We had curves and straights, and that was the end of it.
Mhm.
And we dealt with it.
Yeah.
And the virtual transition that we know and love in this country, you try and introduce that concept to another continent, and they go, what? A virtual transition? Well, tell me more about this. I think it's something involving the police station,
Yeah.
somewhere, but. It's a difficult concept to explain to others
Mhm.
of that comfort, but actually, in bogie passenger vehicles, virtual transitions are perfectly acceptable in terms
Yeah.
of comfort.
It does have to be TSI compliant. Yeah. Because the reason I'm asking that, a bit like a sort of leading question there, see for Forest, we had an issue with TSI compliance with action counters,
Mhm.
passing routes, clearance points, and fill points and all the rest of it. And to accommodate the Eurostar, we can find its way in Elgin and Forest if you're not gonna happen, right?
Yeah.
So,
And sleeper spacing.
and sleeper space and all that sort of stuff. So you're talking about sort of traps there and how to move the clearance point back. Was that based on TSI compliance for this overhang? You use it what 4.8 meters and all,
Yeah,
and all
yeah.
that sort of stuff.
It's just a coincidence, Mark, today.
Yeah.
Into the TSI compliance. Clearance point, and see, obviously, the track, as far as track is concerned, we take the clearance point at 5.8 meters, which is TSI compliant. But then in our standards, it says 6.6. For signaling perspective, the overhang and the safety margin, if you include both of them for the TSA compliance, it is 5.8. 5.8 is sufficient.
Because what we found for us was, I'd sort of worked out for two ends as the forest looked, but we were like 54 mil non-compliant.
Yeah.
So I said to David Council, somebody out in boots, this sort of, actual counterback 54 mil, will we be compliant, David? Right?
Yeah.
And it ended up being, we had about 24 meters at one end, 24 meters at the other. So
Yeah.
we're well within it.
Yeah.
So I was just wondering if there was a space to maybe sort of do that.
My understanding is that you can have a distance of less than 5.8, but it needs to be risk assessed.
Mhm.
And I think the crux of that risk assessment would be what traffic is running. And is the overhang on the traffic that's running that size, in which case you'd be able to bring it right back.
So then that goes back to, is there any intention of the likes of the Eurostar and the Javelin and all the rest of it, we're going to make it, so we want the EG and it,
That's all
in Glasgow.
interoperability, isn't it? And
It sometimes depends on what the NMAP panel determines that your project falls under a particular set of guidance.
Yeah.
If they say it's not RIR, requirement, it's not required, then you can afford to avoid the group standards, real industry standards, everything.
Yeah.
You just do what you want.
Sorry, Russell's not there anymore, so you got.
Yeah, I think the answer is it should be TSI compliant. Yeah.
All right, Tom's asking, trap points, surely flanking protection could have been achieved by alternative means and the trap point deleted from the design.
Top points were a bit high button shoes, by the way. They did. The signal engineer is now going to really justify the need for flanking protection. Dropping trains in the floor belongs to bygone era.
Yeah.
What we tend to do these days is depend upon TPWS, other means. A little bit of track, a little buffer stop. We don't want to drop things on the floor because when you drop something on the floor, it costs a fortune to bring it back on the track again.
Yeah.
So trap points really should be justified for their inclusion rather than say, well, that's the starting point, it's a trap point. The starting point is plain line, justify the inclusion of the trap point. And I would have thought when I saw trap points, I thought, oh, sure, no, in this day and age.
I think we had this discussion in Blaine.
Yeah, possibly. I mentioned it on the down branch goods loop. There was a set trap point at each end that were recovered as part of this project. And the reason was it was no longer classed as a goods route. But when it comes to the down goods loop on the E&G, those trap points were reinstated, or they were kept. So it's obviously to do with the classification of the route. And they're still seen as being required.
So the concern's not a runaway, it's a span.
I think so, yeah. Understanding that.
There's no way cheaper to keep the trap points than
Span
recycle.
at West Wago Junction.
Again,
It'll be cheaper to keep the trap points than to recycle to get rid of them.
possibly.
All right.
Yeah.
It's always a bit nervy planning works over the festive period. What contingency did you have in place for, say, Kirov crane failure?
Good question.
There's a whole.
Switch it off and switch it back on.
Did you have, you were thinking, what happens if, Christmas coming,
Yeah,
lots of people hanging out, crane, we're depending on that,
It's fine.
yeah.
the lights go out, what do you do?
I don't know, Eddie, I don't know if you can hear me. Eddie's on the call. I don't know if that's something you could answer.
That was something. Can you hear me?
Yeah, I can hear you, mate. Yeah.
There
So
was
the question was asked about contingency of key parts of plants such as a Kirov crane. Did we have any contingency for that?
You get 30 seconds.
We asked if there was a third Kirov, and the closest one was somewhere like Manchester, and it wasn't available until we should all been in. All our panels should have been in the deck and basically getting tamped and things like that. So the good thing about what our plan was that all the panels were decked. There was no tandem lifts required to lift off tilting wagons. All the panels were on the deck, so that meant that if any of the Kirov did fail, any of the bigger panels that were tandem lifts would have been knocking bearers off and lifting them in at a lighter weight and then putting the bearers that were knocked off back in. Thankfully, that didn't happen, so it is always something that we consider. And Kirovs, they're a finite resource, so everybody's wanting them, especially at Christmas, Easter, they're a kind of high priority item. But it was included in our PCP, what we'd be doing. And there was enough time in our plan that if anything did happen like that, there was time up our cuff to be able to put them in lighter panels.
That's a great answer. You've got £64,000 now. Thank you.
I was just going to say, Eddie, it's worth mentioning though the whole process to that, the whole peer reviews and everything you go through that basically question absolutely every scenario, don't they, and say, what if, and there comes a point, you can only have so many spares and so many people on call, but as long as you kind of covered what you can, there's a point you've just got to go for it, isn't there?
Yeah, I mean, there's a QSRA that the risk analysis team run. That's every permutation you can think of. What happens if the road trailer breaks down in the first shift? What happens if this doesn't happen, that doesn't happen? What happens if it's windy? So that considers everything, and it tells you what likelihood the job of being delivered within the possession. And it was between 90 and 95% confident in this one. So it was a fairly robust plan that we had.
What happens if Santa doesn't come?
I suppose it could be argued that there's so much contingency in there, and you ain't going to fail.
Yeah. Well, that's
These QRSAs are all right to an extent, but it depends what you feed it. It depends on your weight things, and if you throw a dose of contingency in there, or your contingency is we don't weld it. Although the QRSA people never could get that concept in their heads that welding is something you can just take out the program, open the 10 program joints.
Yeah.
You'll open it one time. You'll never get the welds done. It didn't work with the mathematics.
It's one of those things where you get challenged for efficiency so much, and then so if you build in spare machines, spare people on call, fitters, it comes a point that, if you don't need all that, it's a lot of money spent, but the sod's law, if you did need it and you didn't have it, you're going to get criticised equally and cause problems handing back. So it's a fine balance, isn't it, between contingency and overdoing it.
We seem to have gone the full circle because we went down the road in the mid-noughties of cutting everything to the bone. I'm trying to remember the name of that initiative. But we really reduced the time. We took all the bunts out of the villages, had a wee bit at the end, and we actually managed to deliver to that. It seems to have now become so risk averse, it's going the other way. It's making the positions longer and longer.
I would disagree with that to a certain extent. That the new digging buckets that we use, they're really, really good. You know, they're bigger, got a bigger capacity, so we're quicker at our times there. So we claw a lot of time back in the digging and the stoning up elements. And then in other elements, the time kind of slips. Run about, you know, when there's between phases of the job, S&C renewals, and sometimes getting the top ballast trains in. So I don't think we're not completely risk averse, but at the same time, it looks as though that we've maybe got a lot of time up our cuff when we don't really. And it is, we curtail the welding, we'll maybe only do one follow-up, we'll maybe only do one core tamp and things like that, just to try and claw back the time. But with timings, it's reviewed to the nth degree. I would say that we're a lot better at building programmes for the construction of track renewals now, and that gives us a bit of comfort.
I think Eddie as well, it's well known that these tampers of stone bores are the things that let you down every time, isn't it? So 100%. All right. Cool. I think a question there from Jonathan Law. Note the use of bearer ties. What's the latest thought on these technically?
I think there's still some people that aren't keen on the use of them, of modular S&C. I think some territories, I believe, for a while were not allowing them on their patch. But I'm not too sure what the most up-to-date thinking is overall. But
I don't know. I think a lot of those down to installation, you know, the torque and having the bearers where they join, having it on the, you know, being a level surface and not peaked or anything like that. It's kind of common sense stuff. But I think there was a lot of criticism of them. But when they looked at how they were installed, it was deemed that, well, it wasn't installed as good as it should be, put it that way. It was interesting at the PWI Trackwork Challenge, all the stuff the guys from State Height as well going on about torque on any bolts, and you know, and how there's a total science behind it, and they were going on about not using torque value but face pressure value, I think they called it, and their torque wrenches can measure what you're actually getting, because you could be hitting the torque but not getting the pressure you need because of the threads being slightly dirty or, you know, defunct. So there's a whole science behind torquing, I think, and I think that's something that should look at. I'd be ashamed to just cancel or delete split bearer S&C just because of, you know, lack of understanding or whatever you want to call it, poor installation. Don't want to use that word, but yeah, it could be those things that lead to it.
I think you're right there, you're using the word poor installation, yes. And I was involved right from the start of the split bearer process, and the difficult ones were where you didn't get your ballast absolutely level. You had a guy in the triple whacker plate, and he was frightened to get right into the bearer ends. And he needs to get right into the bearer ends, otherwise you get a wee windrow of ballast in there. And the shroud is doing things that it's not designed to do.
Yeah.
So it's all in the preparation of the bottom ballast.
Is everybody using the approved kit for topping up the bolts? We use Losomats and things like that. Does everybody use them? You know, further down the line.
I think what Greg's saying is absolutely right. You know, to say you can put the design torque in it, but you're not necessarily getting the clamping force, and that's all down to the alignment of the screw, whether there's cramp got into the hole. You can torque it up to however many newton meters, but it's not necessarily closing that joint as it should. And you can use whatever kit you want, but going by torque alone, you'll not necessarily get there unless it's clean, you're careful with it, and you're actually observing that you are actually getting the thing calmed down right.
Calibration as well, your torque wrench.
Could the bolts be getting over tightened as well if they're just getting banched up? You know, the guys just sometimes banch them up. I've seen that happening. It's just as tight as it.
Yeah.
Well, that's the thing is everyone does it just one more fill up kind of thing. You make sure it's tight, and that's you just burst it. So.
Even go back to your conventional base plates and chair screws, how often do you see ferrules that are sticking far too far up or are crushed into pulp? Yeah,
Both of the above.
both of them are
On the same base plate.
Aye,
Was the splice detail on the bearers was changed recently? Was not something changed on the, you know, the rubber pad that goes on the end? That detail was changed not that long ago.
I'm sure about that.
There's an ongoing experiment down south somewhere, I think, in your roads that's reducing the amount of bolts that are going in.
is there not a completely different design coming in?
I think there's
yeah,
a
there's
It's more
European
some kind
design.
of articulated joint
Yeah, there's-
rather than the rigid shroud.
There's a trial place down south.
Yeah, I think there was a
What-
lunch and learn on it at some point.
I can't remember. Andy Blakely showed us a picture of them at one of the, were you not there?
Don't know. Don't remember
You're not paying attention out there.
Oh, I see. I'm sure there was something on one of the lunch and learn.
There definitely is, there's an alternative detail that one.
It certainly seems a lot more flexible, which maybe solve some of the problems, but it's going to create others, isn't it?
And a question about technique, David, wouldn't mind skipping back a couple of slides to where the S&C unit was being lifted.
Sure, yeah.
Just to see what was kind of strops running about. Something I couldn't really see where one was. Yeah, that one.
Yeah.
So the strops there are around about the rail.
Mhm.
Right, lifting the rail. But the bearers are then exerting a downward force due to their own mass.
Yeah.
And in the past, that has stretched the odd clip or two. I have pictures. Would you not consider it a better methodology to actually put that strop round about the underside in and out of the bearer and lift it from the bearer up rather than the rail with the bearers dangling from it?
I quite agree with that, Tom. We did go through, like yourself, your AC clips getting stretched. I stood in the snow at Elvenput and like clips breaking and flinging past my ear.
The whips are shells, they are.
When we first used the Kirrow 250s, it was down at Greenhill Junction, and it was all done under early deployment. One of the things that we did do was we went for the cheapest, nastiest drops that we could buy, and they went under the bearer and you cut them. They were sacrificial, and we were lifting under the bearer, and I thought that was an awful lot better.
But that was always the problem when you
Yeah.
lift under the bearers, like when you lay it on the ground, oh.
Well,
Oops. Yeah, cut them and leave them.
But we seem to have been back to lifting under the rail again, or lifting round the rail.
It tends to be from a perspective of where you are. I need to lift this panel. The assumption's made that the panel can withstand the self weight of the bearers. And some of these bearers are quite long, and quite heavy, and not held by very many clips, some of them. And it stretches the clip.
Yeah.
And that
I take your point.
you sometimes can't
Aye.
see it.
Yeah.
You have to get quite forensic to see that, hang on a minute, that clip looks as though it's in, but actually I could put a fact paper
Yeah.
between the clip and the rail here.
Aye.
And it's not actually holding any kilonewtons on the tow load.
The other piece of technique you really need to consider as well, Tom, is when you're lifting the movable section of the switches. The last thing you want to do is put strops round and the open side of your switches.
Right.
Not doing them any favours.
No,
I take your point. I can ask the question to see if there's any reason other than it being the easiest way to do it.
I'm only saying this
Aye.
to educate the next generation
No. Aye.
into thinking, oh, hang on a minute, I heard that at PWI meeting that one.
Aye. I take your point.
Even when you've got the lifting beam on, it's still just lifting the rail as well. It clamps onto the rail and lifts it for the the head of the rail. I think the only reason that they do it like that is what the picture shows is because you can then get the straps out. If they were sitting underneath the bearer, you couldn't get them out; they'd be stuck.
Yeah,
Correct, yeah, that's the issue.
aye,
And that's why people wrap the strops around about the rail or, strangle wrap it or whatever it is and lift it by the rail. But some of the heavier concrete bearers, and it might not happen in the future with, composite bearers and steel bearers and the like.
aye.
But for a reinforced concrete bearer, downwards, the load is quite excessive on the pandrel clips.
Yeah. So you just have to have a method to avoid whatever the lifting component get trapped underneath. Just grounded, not sure what that would be.
Sacrificial.
Yeah,
Yeah.
yeah.
Could be, just have to allow time, Eddie, for reclipping all these to show they've got the right tool loading.
I think it's worse if it starts bouncing about.
Aye,
Yeah.
good strain, yeah.
That's all the questions on the chat. Don't have any more questions in the room? Oh,
I had one question just on the structures. Structures seem to be very adverse on any risk these days. Sometimes I think on this scheme must have been a major scheme costing millions. What were those conversations like with structures? Were they quite helpful, or did you have to really push them? Or I know that RSA have now got a structures engineer, which is really good practice, but it's quite interesting, that whole structures issue, which seems to be an issue on every single renewal or even TAMP these days.
there's a lot of swearing involved. That's how the conversations been.
I think they're very helpful, Jonathan, but I agree with what you're saying about recently. I think they're far more risk averse than they've been in the past. That's definitely the case.
Is that part of this keep falling off?
Hmm?
Oh, part of this keep falling off.
Yeah, aye, because of quite high profile incidents and aye, they're obviously coming under a bit of pressure. But yeah, they're good to deal with, but definitely more risk averse, I would say.
Look at the situation in Busway as well, so there is a restriction for a plant bridge.
Jumping back to design into
With them being busy people, we're not necessarily that high up the to-do list either. So it can take a few prods and probes to get the answers that we need.
Yeah, but it's you know what I mean, Eddie. Like you're changing. It sounds like there was a good workaround for this one, but changing the layout of designs or even components without, I don't know. Part of me feels like, yeah, it's just difficult, isn't it? Yeah.
I think there's a bit of work that still needs to be done to carry out a bit more joined up thinking. Our jobs are known 3, 4, 5 years in advance. And like I say, we're no top of these guys' priority list. So when we go to them, a year, 18 months before the job to say, right, this is what we're going to do here. Is there any issues here? It's, oh no, that there is. What can we do? All right, we're not really sure. Because if they were thinking 5 years in advance, we could maybe be saying, well, see, instead of having a 54-hour possession, we'll get a 96-hour possession. Rail systems line, strip at the track, whatever. We'll do some structures intervention work, and then we'll back in, so that it's all happening at the same time.
You got a do not tap sign on that bridge now?
I don't think there is. No. But there's
Should there be?
I think it was more to do with the positioning on the bridge rather than the whole loading. It was they wanted to, so they done that in Green Morning as well, didn't they? They wanted to move, just I guess, to spread the load in the right way for the structure, whatever reasons well. But
I don't think it would be too much of an issue over lift. But yeah, if somebody wanted to slew, aye, it was the slew that was the issue. Aye. Aye. Sorry, Jim.
design integration, particularly with the overhead line people.
Mhm.
You mentioned there were 14 recoveries.
Yeah.
What you did was not just a like for like relay, nothing like a like for like relay. It was a complete remodeling.
Yeah.
Given the length of time of the gestation period of this project, the up loop or the down loop, whatever loop you want to call it, depending which part of the junction you're on,
Yeah.
that happened pre electrification.
Mhm.
Was there any cognizance taken during the Egypt electrification project of this known entity of a remodeling?
I don't think so necessarily, but I think when the overhead line design guys on our side started looking at it, generally speaking, the fact that there was portal structures all the way through it, they were quite relaxed about it because there was far more flexibility in terms of what they could do because the stuff was new and it was all portals. That made their life much easier. So in that respect, the recent electrification package, and that's recently done, worked in their favour.
Did the location of the new overhead line structure influence in any way your design relative to when you put the switch close, for example?
No,
So no influence at all.
no. I think if it had been older electrification and different types of structures, yeah, it might have done. But I think the fact that there was so much flexibility in that system being new and the fact that they're all portals, there was scope for being able to move the cantilevers around.
Okay, thanks, David.
One question for Eddie. I think he's still there in me. This climate of efficiencies, were you able to measure the efficiency throughout the project? You've been able to do that so you can deliver to the client themselves. This is what we've delivered. Is there anything you've used throughout the process? You used anything technology or anything that's helped you deliver that? Anything that's I mean, it's also the sustainability argument. Did you measure your carbon throughout the process, or is that still at the early stage for that?
The job was delivered as efficiently as it possibly could. All right. So no, not a lot of manpower on the job, and but bearing in mind that this job was sort of even though the possession on Christmas Eve, the track renewal didn't start until the 26th of December. All right. So we had guys out working elsewhere, Christmas Eve, Christmas Day, then coming out to work for us for that week, and then the track renewals was complete by the 31st of December, right? And a lot of if you go into one of these sites now, you'd be shocked at the amount of staff that's on it. There's not a lot of staff on these jobs anymore. We kept the trains down to a minimum as well. Unfortunately, to keep the brakes and things like that operational on the trains, the engines need to be running all the time. We're not there yet with the likes of battery powered road railers, things like that. We're in an environment where we're still having to use concrete sleepers, ballast. So it's probably not one of the most environmentally friendly sites. But we're just not there yet with the materials to use. The carbon tool element, that we do use that, but at the same time, it generates a figure, and who looks at that other than us? It's until there's some sort of KPI or KRA that we're getting scored against, and somebody tells us that our aim should be that we're below a certain number, then it's useful to know, but it's not quantifiable. When you look at the carbon tool, it's asking you things like, how did you get your site lighting to site? What came in a lorry? What type of lorry was it? You know, where did those lights come from? This is all stuff that it takes a lot of time and effort to get that detail. And if it's not really quantifiable at this moment in time, yeah, like I say, it's good to know, but I think a few wee, no, it needs to be looked into more detail as to why we're doing it and what the objectives of doing it are.
See, you won't be voting for the Green Party anytime soon then, Eddie, is what you're saying?
No. I'm all for, you know, trying to get things as environmentally friendly as possible. But at the same time, there's a lot of technologies that we're not there with yet.
I think you're right. I think the way forward with this is to have a dollar value, a pound value against the component, the material, and beside that have a carbon value and have two tickets, a ticket for price and a ticket for environmental cost. And that goes with every machine hour, every component, every sleeper. Is it steel? Is it concrete? Is it composite? What's the E number ticket, the embodied carbon element in that item? What is the embodied carbon element in a 90 metre up to 45 millimetre track lift? What does that cost? I can calculate that. We've got a carbon tool. You might have a carbon tool, but we need an industry standard carbon tool. Our SSB are working towards that, but they're miles off yet.
Yep.
If you want to get down to the granularity we're talking about here, you're going to have that by item. Can you imagine trying to determine the difference in embodied carbon between a CV9.25 and an SG28? You need to know the length of every bearer. You need to know the weight of every component.
Yeah.
You need to know how many. Right? Okay. You can calculate it from first principles, but if you have the basic data, then I'm quite sure somebody can invent a little AI tool that would calculate it for you. And that's where we need to go in the future. We need to use tools that are available to stop the human slog and say, tell me, AI, what is the embodied carbon content in the switch I intend to use versus another one? Or this 1 kilometre of relay in concrete sleepers versus the same in steel or composite. What is the difference? And that's the argument we need to sell to our clients and the funders and the sponsors. And that's the only way at the dilemma we're in. We want to push it forward as engineers. We are environmentally sustainable like everybody else, but who's got money?
At this moment in time, you mentioned composite sleepers there, Tommy. See if you want fast clip base plates on them, you can only get them for Australia at this moment in time. So how did that affect your carbon footprint?
Yeah, when you look at your composite sleepers that are coming from Japan, that are made of glass fibre and some kind of resin, which of course is a product for the petrochemical industry, are they really environmentally friendly? Give me a bit of hardwood from a sustainably managed forest anyway.
Shortly to be opened up in a factory in Eastern Europe. Single on my lips, I said.
Aye.
Coming closer, but it's not just in the road, at least or somewhere. Cycle. Yeah. There's something in some country.
Okay, any last questions or comments? Anyone? All right, let's move on to vote of thanks. So thanks, David, excellent presentation. Took us through the history of the previous stages of the upgrades to Greenhill Upper in 2015 and then went on to the scope of the 2023 works. You mentioned the tremendous effort to achieve T-12, which is a testament to the collaborative efforts of all the three parties in the alliance. I'm not sure T-12 will be repeated again, but we can but try. like any project, it's not without its challenges, and you covered them excellently with the structures loading and the radius at the trap points is great examples. I think another key factor was the integration with the GSRP project, and which was another considerable project in the area. And again, you covered how the regular integration meetings were vital to the success on that front. Also great to see you didn't just focus on PWI element, as these projects are very much interdisciplinary, and indeed the focus can be on track, but that's probably the most visible change on a site, but sometimes the associated discipline designs are the more challenging than the track stuff itself. Construction side was covered well, and interesting to see the prep that goes into a job like this. Some people might think everything appears on the first night of the core, but you quite rightly pointed out there's a lot of deliveries and a lot of prep work in advance of the main core. The challenge on the loading of the structures thing during construction is going to be an ongoing challenge to other sites. I think just as we've discussed, the modern weight and size of these panels combined with the Kirov weight on aging infrastructure is going to be a challenge. But it's great to see some novel solutions from construction that can overcome that. And lastly, some great statistics as well. We showed one of your slides, which is always, I think, these slides are always interesting. It gives an idea of the scale of the job. So the number of welds always strikes me, and I think you got it there, 179 welds. When you think about that, it's just phenomenal statistics there. So just thanks again for that, David. I'll just ask everyone to join with me, and thank you for that presentation. Okay, for those online, I'm just going to finish the call there unless you have any last comments. Okay, thanks. Yeah.